Hello, and thank you for joining us on our lecture about resistor networks and circuit configurations. Let's start by talking about adding resistors in series. Resistors are in series when one end of the resistor is connected to the other. Adding resistors in series is as simple as just adding the resistor values of each resistor. So the total resistance is equal to R1 plus R2. Here's an example. The first resistor is 10 ohms, the second resistor is 5 ohms, and the third resistor is 5 ohms. Now if we wanted to find the total resistance, we would add all three resistor values up and get a final value. So that will be 10 ohms plus 5 ohms plus 5 ohms equals 20 ohms. In addition to having resistors in series, resistors can also be wired in parallel. When resistors are wired in parallel, they are directly wired together from one node, node A, to another node, node B. To solve for the total resistance of resistors in parallel, we use this equation, where it's 1 over the total resistance is equal to 1 over the sum of the resistances. So it would be 1 over R1 plus 1 over R2 plus 1 over R3. A short, quick way to calculate this for having two resistors in parallel is the total resistance is equal to the resistance 1 value times the resistance 2 value over top of resistance 1 plus resistance 2. Now, let's do an example of adding resistances in parallel. To do this, we could use the equation stated before of R total equals 1 over R1 plus 1 over R2 plus 1 over R3. Or we could use the equation of adding two resistors in parallel twice, which was R equals R1 times R2 over R1 plus R2. So let's try this first with these two resistors. This will equal 20 times 20 over 20 plus 20, which will equal 400 over 40, which will then equal 10. Then we can say that this is an equivalent resistor is equal to 10 ohms. So we can redraw it as two resistors, the first being R1 of 10, and then the second resistor being the resistance we just calculated of 10 ohms. We can then do this calculation once more and say that R is equal to R1 times R2 over R1 plus R2, which is going to be equal to 10 times 10 over 10 plus 10, which will be equal to 100 divided by 20, or 5 ohms. Before we move on, it is important to talk about voltages in parallel. When we have two circuit elements that are configured in parallel, it is important to note that the voltage dropped across them is equal to each other. This means that the voltage across the first element, V1, and the voltage across the second element, V2, will be equal. Now let's take a minute to go over the different types of basic circuit configurations. The first is a closed circuit, which can be seen below. A closed circuit is a circuit that encapsulates a closed loop. The next basic circuit is an open circuit, which does not complete a full loop. No current will flow in an open circuit. The top portion of this circuit will be energized at the rated value of the voltage source, whereas the bottom will be at 0 volts. The last type of basic circuit is the short circuit, where a connection is made in between the source and the load which will provide a path of least resistance. This will cause the 5 volts to be dropped over something that has an extremely low resistance, causing high current values. Now let's practice combining these resistance values into one resistance. Let's first start with these two 25 ohm resistors in series. To get their equivalent resistance value, we're going to add them in series, so R equivalent 1 will be equal to 25 ohms plus 25 ohms. So this will be equal to 50 ohms. Then we can redraw this as 100 ohms, 50 ohms, and our equivalence value of 50 ohms. We can now add these two 50 ohm resistors in parallel using the way described before, where R equivalent 2 will be equal to 50 times 50 over top of 50 plus 50. This will be equal to 2500 over top of 100, or 25 ohms. We can then redraw this circuit once more and have 100 ohms and then another equivalent resistance of 25 ohms. Our last calculation will add these two resistors in series, leaving us with a R total value of 100 plus 25, which will equal 125 ohms.